Math 1B in Geometry, coming at you with a new video. It is lesson 1.10. We're making the switch over from graphing linear equations, even if there's just two of them. It's all pretty much the same thing. Inequalities have a much different feel to them. But in many ways, they're very similar. So just checking this out. What does the graph for y is less than 2x minus 1 look like? So the first thing I would start with is just say, well, what does y equals 2x minus 1 look like? And we know what that looks like. It starts at -1 on the y-axis. And then it travels up to right 1. Or down to left 1. We normally would connect the dots. And we'd be done. But here's the thing. It's not equal to. It's less than. So here's how to think about this. Y equals 2x minus 1. When we graph this line, remember when we solved equations? Remember back in the good old days when it was something like 2x minus 1 is equal to 3? And you just add 1 to both sides and divide by 2? Your solution would be x equals 2. The solutions for y equals 2x minus 1 are all the dots on this line. So, all the dots on the line are for y equals. When it's y is less than, it's all the dots under the line. All the dots under the line. So, we're talking about this entire plate. You know what? Here's what it looks like. I think I can do this. Yeah, it's all of this. All the points in this shaded region represent solutions to the system, or to this inequality. Every single dot below this line represents the solution to the inequality. So what you guys got to do on this homework is you got to shade. You got to shade under, for this one, less than means, whoops. Less than means underneath the line. So then here's what you got to do. You gotta draw the line and then shade underneath it. And there's actually one other thing we gotta keep in mind. Let's see here. Good. You have to dash this line here. Sorry, I wasn't expecting to use that, but it just came in my mind that I've got that at my disposal. You have to actually create a dashed line to show that this thing is less than. All right? So the line isn't included in that shaded region. So it's kind of like an invisible boundary. And to show that it's an invisible boundary, we dash it. Okay. So what does it look like for it to be? Okay, that was the solution. I just explained it. The solution was the shaded region down there. So you might want to write in your notes, the solution is all the points in the shaded region below the dashed line. This dashed line, not that dashed line. Okay. Now, below this, I told you guys to check out y is greater than 2x minus 1. It's basically the same thing, except instead of shading underneath, you're shading overhead, because greater than means above this line. So I'm just going to use this same grid space, but you should graph it in the grid provided below. The shaded space is going to be all of this above the dashed line. So that's the answer to number 2. The solutions to this, are all the dots in the shaded region above the dashed line. All right. Let's check out what's going on below here. Oh boy, come on now. Help me out. This is entertaining for you guys, yeah? All right. Okay, good. Oh, here's a good question. What would be the difference between greater than and greater than or equal to? So it's the exact same line, up 2 over 1, up 2 over 1, up 2 over 1. This equal to means that the line doesn't have to be dashed. The line is included now in that solution. The line is included in this shaded region. Yeah. So the thing that you can remember is if it's greater than or less than, you need a dashed line. Okay? If it's greater than or equal to, you need a bold line. I don't know. I don't know if that helps, but that's what you need to remember. Okay, some examples. Number 3. Oh boy, come on now. Help me out. There we go. So it looks like the only difference we really have to take advantage of, or not take advantage of, the only difference with 3 and 4 is that, hey, y is not by itself. However, you guys have been getting y by itself literally since the first week of school. So I see 1x minus 3y is greater than or equal to 5. The process is no different. You're trying to get y on the left, mx plus b on the right. So subtract 1 from both sides, 1x, rather. So you get negative 3y is greater than or equal to negative 1x plus 5. You're going to divide both sides by negative 3. And Maybe you guys remember this from Math 1A. Maybe you don't. Dividing both sides by negatives switches the symbol to the less than sign. So make sure you keep that in your memory bank. 1/3 is our slope x, and then this one's going to start at negative 1 2/3. That's what 5 divided by 3 is as a mixed number. So we're taking this. We're drawing a bold line, not a dashed. Starting at negative 1 2/3, that'd be down 1, down 2/3 more of a block. And then you go up 1, right 1, 2, 3. Up 1, right 1, 2, 3. Down 1, left 1, 2, 3. Down 1, left 1, 2, 3. Draw a bold line. Less than or equal to means below the line. I'm going to fill in everything below this line. I'm keeping it bold. And really keep in mind that this solution set isn't just here. I mean, it goes on forever. I mean, it keeps going forever underneath this line. Forever. And it keeps going this way, so it's forever over here. I just wanted to draw more on that, so. But no, that's an important concept to remember. It's important to recognize that this is just a small window of the solution set. It's not the entire thing. So check out number 4. This looks different. I see 2x is less than 4y. My first thought is to rearrange it so that the y is on the left-hand side, and you have to do it with inequalities, because the direction of the inequality symbol, greater than versus less than, makes a huge difference. So if I rewrite this, watch what happens here. The 4y, if it shows up on the left now, I switched from less than to now greater than. It's all from 4y's perspective. And now I just divide by 4. So this is y is greater than 1/2 x. Remember to put the plus 0. All right, we got it. This is a dashed line. So starting at 0, go up 1, right 2. Up 1, right 2. Down 1, left 2. Down 1, left 2. Down 1, left 2. It's a dashed line, so look like this. Greater than means shade above the line. And then you're done. All right, this video is running a little bit long, but I'm going to do the special cases before you guys check out. Whoa, no. Okay, get out of here. I'm learning so many things. Okay, so the special cases. And I'm not talking about, remember last lesson, parallel and all points on the line? I'm not talking about those special cases. I'm talking about just vertical and horizontal lines. Like, what are you supposed to do if they show up? Well, I'm still counting on you guys to understand that x equals is vertical and y equals is horizontal. So think of this as the line x equals 3. If this is our y-axis, this is our x-axis, you would draw a vertical line 3 units to the right. Okay? Instead, though, this is a less than symbol, so it'd be dashed. And you really can't shade above or below a vertical line. And you can't be like, okay, I'll shade below the line right here. That is the line. So you have to think more in terms of left of the line or right of the line. So what do you guys think? Less than, left of the line or right of the line? Well, less than should be left of, because these are all the solutions that are smaller than 3. 2 is smaller than 3. 1 is smaller than 3. 0 is smaller than 3. Negative 1 is smaller than 3. I'm just using the x-axis, counting that way. So you would want to put your shaded region over here. So if it's a vertical line, literally just follow the arrow. It's less than, you're going that way. If you check out the y's, you're going to get a horizontal line. Here's my y-axis, here's my x-axis. Negative 1 would be down here. And then you ask yourself, hey, does greater than mean above or below? Greater than, bigger than, above. All right. Thanks for watching, guys. I think that covers it all.